Hello everybody, welcome in the presentation of the challenge 2 of the Open Spring INSPIRE Hackathon. The challenge is focused on regional attractiveness and assessment of regional attractiveness based on exact data. As I mentioned, the main goal is to explore and develop different forms of simple and understandable and attractive communication of regional attractiveness assessment. This assessment is based on exact data, exact statistical data, and the attractive communication follows mainly maps and other graphical and cartographic products. The challenge has 6 registered but only 4 active participants from different countries on Europe, and the challenge was mentored by Otakar Čerba from the University of West Bohemia in Pilsen, Czech Republic, and by Karel Charvat from Plan for All. Something about methodology of our challenge. We started by brainstorming, and this phase, brainstorming, found several issues to be solved. So we divided our team to 4 groups. First group was focused on data, on searching and describing new input data sets for regional attractiveness assessment. The second one was about semantics, about development, the ontology, describing input data sets from different perspectives of regional attractiveness. The third group developed and improved interactive web application. And the final last group was focused on synergies and cooperation with other challenges of the hackathon, mainly with challenge 1. And we tried to implement methods used for assessment of regional attractiveness, such as clustering, for other types of data. Now, the particular groups will introduce their results.
One task of our challenge was to search for more data on regional attractiveness for African countries. We already had some data on regional attractiveness for Africa, but we definitely needed more. So we performed a search, which was guided mainly by some lists of relevant keywords related to regional attractiveness. These lists of keywords, they came from 2 documents of the project Polyrole and also from 1 research paper also dealing with regional attractiveness. And we had already used these same lists of keywords also to inspire our search for European attractiveness data. So we used these keywords to build some search strings, which we put into Google, and then we found some more specific databases, which we then searched in detail. And you can see these databases here, most of them at least. So for example, World Bank. And with that, we found so far 41 data sets. To be able to tell a little bit about the nature of the data, we tagged this data with the same tags that we also used for the European data. And so you can see that about 2/3 of the data is on social and economic issues, but we also found some data on anthropic, natural and institutional issues. The only thing that we haven't found data so far is cultural aspects. And the other graph shows where we found our data. So here the biggest, almost half of the data comes from the World Bank, another big slice from the food and agriculture database called Aquastat, and there's also data from the web page of the World Happiness Report, where we found data on life satisfaction, social cohesion, and so on. About the data quality, we can't tell so much so far because it would require a deeper analysis of the data, but we can tell already that most of it is on national level. We haven't found a single database on a subnational level. And we can also tell that half of the data is from 2020 or 2019, and that almost all data is less than 5 years old, and I think that makes the data pretty up to date. The most obvious next step for our search for data is, of course, that we will continue the search because it feels like there's much more to be found. And then we will also have a deeper look into the quality of the data. And then finally, we will select the data sets that will form the databases for our application.
So I would like to present the semantics of the input data that are suitable for assessment of the regional attractiveness. Since our approach to the regional attractiveness is based on statistical data, we have to deal with large number of diverse and very extensive data sets. That means that the harmonization of these data sets is an essential condition for their further processing. And also the description of data using metadata is very important for understanding of their meaning and for further applications. That's why one of the tasks of this challenge was the semantics of the input data. We focused on data classification and its description with regard to different approaches to attractiveness. For this purpose, we developed an ontology that deals with general concepts of attractiveness, and the ontology should cover many different approaches to research and evaluation of the attractiveness of regions. In the picture, you can see the diagram of the core structure of the ontology. There are the main defined concepts of attractiveness, also with their properties and relations between them. As you can see, the classification is focused mainly on the data, their sources, coverage, level of detail, and update. However, the ontology also includes general classification schemas as United Nations SDGs, Gemet or null taxonomy, and as well as a polyrural classification. These classifications consist of various groups. Here in the left, you can see such groups for the polyrural classification. On the right side, there are the individual data sets that are assigned to these groups according to their focus or topic. Other characteristics of the data sets are also shown there. And so that was a very short overview of one of the particular results of this challenge that was focused on the semantics of input data and on development of the attractiveness ontology. That would be all for me, and I thank you for your attention.
Dear listeners, my name is Jan Matura, and I'm going to show you our web map application for regional attractiveness. You can find this application under the Hub Polyrural project, or you can access it directly under the second URL on the site. I will now show you how to access the application from the Innovation Hub. Here under the option Apps, you can access the option EU Rural Attractiveness. Once you open this option, you can see a description, and from here you can navigate yourself via this link. Once you open the link, the application starts loading. It takes a little bit of time as some calculations are going underneath. Right after everything loads, you can see multiple things in the map. Obviously, we are looking at Europe, so let's investigate what you can see exactly. Here on the right side in this panel, you can switch to Layer Manager and you can turn on or turn off individual layers. Here we have several layers available. First is a layer of pilot regions for the polyrural projects, shown in green. Then you have a layer of regions in a classification NUTS2, and there are next two level layers which are NUTS3 regions, and these are our primary focus because we are displaying the attractivity or attractiveness of these NUTS3 regions. So first we display the rural attractiveness calculated via index. It's this layer. And then we have another layer which is calculating clusters with similar attractiveness. You can do some more stuff like changing the opacity of the layer. You can turn off the background map or turn it on again. You can see the legend here and some other stuff. Now look specifically at some region and its attractivity. I will turn on the layer with Rural Attractiveness Index and I will search for some region. For example, I will focus on Karlovarský kraj, which is a region in the Czech Republic, and one person once told that it's the worst region in everything ever. So let's look at what we can see here. And we can see that if I hover the mouse over some polygon of the NUTS3 region, you can see the value of the index. It is displayed here as a percentage calculated from the information given. You can access more fine-grained detail under this link in a new page, where you can see a very specific values for individual categories and individual datasets. So we can see that, for example, the region of Karlovy Vary has a very low score in some social areas, but it has some much higher score in institutional areas or anthropic areas. What are these categories at first? So let's go back to the application and look how we can play with these categories. In the right panel, I will switch to the panel which is named Adjust Factors, and here you can see exactly those categories which are related to rural attractiveness. These categories further include individual datasets, and if you play with the options here, you can give a higher value to individual categories, and you can turn on or turn off some datasets. You can find a description of the datasets if you click on the name. So let's change some of these values. Let's turn on some of the datasets, and we can calculate the value again. As you can see, the calculation takes some time, but you can immediately check that the map has changed. You have the option to calculate only the index of the attractiveness or only the clusters of the attractiveness. So let's try only calculating index, which is much faster, by the way. And we can investigate the values calculated from the pop-up window. Now try to recalculate the clusters. I will change the layers turn on the clusters and zoom back to Europe, which you can, by the way, do with this nice button. And I will recalculate the clusters. Let's say we will create 9 clusters and we will look how the map of the Europe will change. So not only you can change these values here and find a suitable set of rules which will display the map as you desire, you can display different clustering methods which will display different results. But beware, not all these clustering methods give meaningful results for all the settings. So you can play around, try this our application. If you don't speak well English, you can switch to another language. If you are very satisfied with the result, you can print the map on the paper and use it as you like. That's all for me. Thank you for your attention.
Okay, something about synergies and cooperation. As I mentioned, it is the joint activity between Challenge 1 and Challenge 2, and we wanted to apply some methods used for assessment of regional attractiveness to the issues on land use and land cover. We worked on 2 training regions, a part of Uganda and the plots of the Rostěnice farm in the Czech Republic. We tried to cluster histograms of remote sensing, and we tested the initial hypothesis that similarities in histograms and particular clusters should indicate similar land cover or land use or even ground crop. The methodology of this part of our challenge was quite simple. First, we tested various methods of clustering and calculations of distance metrics. We used hierarchical clustering, so therefore it was necessary to calculate distance metric at first. We compared results of clustering and real data about crop, and after that we made a detailed evaluation of pre-selected methods. As a result, we have the maps of the clusters and some validation of results. First, comparison of different methods and different ways of calculation of distance metrics. These calculations are in columns of the colored metrics, as you see on the left side, and clustering methods are on the rows. The numbers are values of error, so the lowest number is the best one, and you can see that we have best results for hierarchical average clustering with Canberra distances or with binary distances. And as you can see in the graph on the right side, also the histogram of results is very similar to original data. Original data are colored by blue line in the graph. Some result map. This is the map of clusters calculated from the histograms. As I mentioned, this is map for Rostěnice farm, and you can see several results. First of all, the red boundaries of plots indicates incorrect crop detection, and the colors indicate some type of crops, for example, dark green maize, dark orange cereals, or yellow, it means canola. You can see that about 60% of classification was successful. Conclusions. Our four groups want to continue in the work dealing with regional attractiveness. The data group plan to integrate new data and make more advanced data processing, include machine learning issues, for example, decision trees or random forest techniques. There will be also the development of new ontological features, interconnection to linked open data, and interconnection of the ontology to the web application. So the web application should be extended by some semantic data, and we also want to improve the application by more interactive input data builder. And last one, synergies and cooperation. We would like continue in this cooperation and to test other types of remote sensing, agriculture, and land use, land cover data. So it is all from our challenge. Thank you for your attention. And if you have any questions, please contact mentors, and we surely answer your questions. Thank you very much.